This is an introduction to absolute value inequalities, and the method that I'm going to introduce is kind of different, but it's known as less means nest. Okay, less means nest, more means or. Okay, so less means nest, more means or. And it's a way to remember how to do these absolute value inequalities. So we'll come back to that. I just wanted to give you an idea of where we're headed with these as we dive in here. Let's start with a simple example just to get an idea of how this works. A very simple example, absolute value of x is less than 3. Okay, and we're going to examine this closely with a number line. Okay, so 1, 2, 3, -1, -2, -3. Let's go up to 4, 5, -4, -5. Okay, so we're going to try to figure out what region this is true. In what region this is true. So let's see here. Let's just take a point in the middle. 0. Is absolute value less than 3? Yes, it is. Absolute value of 0 is 0, and 0 is indeed less than 3. So that's in there. Let's try 2. Well, absolute value of 2 is 2, and 2 is less than 3. So 2 is in there too. How about -2? Absolute value of -2, is that less than 3? Well, absolute value of -2 is +2, and 2 is less than 3. So -2 is in there as well, right? And you can imagine -1 is in there, 1 is in there. How about 1/2? Yeah, 1/2 is less than 3. -1/2 is less than 3. So all these points are going to be in there. So let's just fill this in, right? All these points are going to be in there. Now, maybe we stop at 2. Let's try 3. 3, the point. Is 3, absolute value of 3 less than 3? Well, no, it's not. Absolute value is 3. Is 3 less than 3? It's not. 3 is less than or equal to 3, but this is not saying that. This is saying 3 is less than 3. It is not less than 3. So we can't include the point 3. So I'm going to put an X right there. And similarly, absolute value of 4, is that less than 3? No. Okay, so that's out. Okay, same thing. How about -4? Absolute value, is that less than 3? Well, that gives us 4 less than 3, and it's not. So that's out. Okay, so this is out. So what about, though, what about 2.5? Is absolute value of 2.5 less than 3? Yeah, that's 2.5 less than 3. That is less than 3. So that would be included. So let's extend this out. Okay, and you get the idea here. What if we did absolute value of -2.99999? Is that less than 3? Well, yes, it is. The absolute value would make this positive, and it would still be less than 3. So that extends it all the way down here. And right, so we can get as close to -3 as we want as long as we don't hit it. And we can get as close to +3 as we want as long as we don't hit it. And what you do to represent that is you put these open intervals here, right? Like so. Another way to do this would be to write it with open intervals with an open circle, both of which are fine in my book. Okay, something like that. And we call this graph notation. So there is the graph of that inequality. And here is the interval notation. Let's just do it right here. Right, we go from -3 up to 3. Interval notation tells us where we start and stop. And stop. Okay, and it goes in order from the more negative stuff to the more positive stuff. So there's that. That's usually what we're looking for in the answer. Well, really both of these in these exercises. But the interval notation is just a way of representing the graph notation in a more compact way. So I'll write this interval notation. Interval notation is there. Okay, well, clearly you wouldn't want to go through this every time, right? That would drive one to some pretty dark places. To sit there and test points, you'd have to test an infinite number of points. So what can we do instead? It turns out that all of these are the same. So let me look at this a different way. Here's the less means nest method. Okay, less means nest. What I mean by that is absolute value of x less than 3. So here's less than. So this works on when the absolute value is on the left-hand side. Left-hand side, LHS, left-hand side, and the number is on the right. Okay, so this kind of less means nest thing. Okay, so this symbol here is less than, and so less means nest means that we nest this like so. Negative 3, whoops, negative 3 is less than x is less than 3. And what this does is it makes our nice little nest. Right? Less, they always look like this. These less than inequalities. See how this kind of made a nest up here? Look at that. It's so nice. Nice little nest right here. And it's going to be the same kind of graph for all these less than absolute value inequalities. So here's our nest. Less means nest. We've nested x happily between negative 3 and 3. We can do it in our interval notation or our graph notation. So here's 3, negative 3, here's 0. We nested in between. We know that it's these soft brackets because it's less than and not equal to. And there we go. There's our graph notation, and we can also go straight to interval notation, negative 3 to 3. Less means nest. If this was absolute value of x less than or equal to 3, it's still less means nest. We just nest it like this. Negative 3 less than or equal to x less than or equal to 3. And now we include 3 in our interval. So let's look at it that way. Okay, so 0, now we'll go up to 3, down to negative 3, and it looks more like this, right? Hard brackets, because we're including 3 now. So instead of going infinitely close to 3 and then stopping short, now we're including it in our interval. There's our graph notation, and our interval notation would be negative 3 to 3. Less means nest. All of them work this way, right? So in general, absolute value of x less than some number c means we nest it between negative c less than x less than positive c. And it gives us our graph, right? It'll be negative c up to c, right? And this would also work for the equal to case. This is just strictly less than. And our interval notation is negative c to c. Okay, and we'll do examples of this as well to make it a little more clear. Let's talk about the other case, the greater than case, the more means or case. Now let's look at the same situation, well, almost the same. Instead of x less than 3, let's look at x greater than 3. All right, we'll just explore it briefly here. Right, here's our number line, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, negative 5, negative 4, negative 3, negative 2, negative 1. Okay, so here we could just test some points. Let's try 0. Is absolute value of 0 greater than 3? So we're saying, is 0 bigger than 3? No way. Oh, whoops. 0 bigger than 3. Nope, it's not. So 0 is not in there. Is 2, absolute value of 2, bigger than 3? Well, absolute value of 2 is 2. Nope, 2 is not bigger than 3, so that's not in there. Same thing with negative 2. Is negative 2 bigger than 3 in absolute value? Well, when we take the absolute value of negative 2, it turns it positive. Is that greater than 3? Nope. And so on. So none of these are in there. Even 3 itself is not in there. Okay, so we're kind of, all this middle stuff is out. Okay, let's try 4. Is absolute value of 4 greater than 3? Well, that gives us absolute value of 4 is just 4, and 4 is indeed greater than 3. So we do include that. And similarly, negative 4 is greater than 3. Right, absolute value of negative 4 is 4, and that's greater than 3. So we include that. Of course, we won't do this every time. This is something we do the first time, just to get an idea of what this looks like. Okay, what about 3.1? Absolute value of 3.1, is that greater than 3? Well, yeah, because 3.1 is indeed greater than 3. So this goes all the way down. You can imagine this at 3.00001, right? As close as you wanted to get to 3, as long as you didn't touch 3, it's going to be greater than. So this is going to give us our soft parenthesis here. And everything bigger, right? 5 is greater than 3, 6 is greater than 3, is going to be included. So now this goes off in that direction, off to the right there. And similarly, negative 3.1, absolute value, is that greater than 3? Well, that's still 3.1, and that is indeed greater than 3. These are checks. So, yes, everything in this direction, when you take the absolute value of it, we get something that works. Okay, so off in that direction. And these greater than problems will always look this way, right? They'll have this hole in the middle, and then they'll go off in 2 different directions. One off towards infinity, one off in the other direction towards negative infinity. And let's get our, so this is our graph notation again. And let's do our interval notation. Our interval notation represents the graph notation. It's a shorthand for graph notation. Here's how we do it, right? This graph started at negative infinity. If we go left to right, negative infinity, it went up into 3, into negative 3. It stopped just short of negative 3. Then it hopped over all these x's. All this middle stuff that wasn't included in this inequality, it hops over it. The way you hop over a bunch of stuff is with this union symbol. It's like a U without the little side thing. It does not have this side part, so I'm taking that off, right? It's like a little cup. Okay, then we hop over that. We start again on the other side, 3, and then off we go to infinity. Okay, so this interval notation should read from left to right. Interval notation. Okay, and these OR cases will always have a similar interval notation if they're over in this direction. If the inequality is over on the left side, more than a number. If this was, in the case of this being x greater than or equal to 3, it would be similar, except for now we are going to include 3 in there. Okay, and we're going to include -3 in there as well. So we do a hard bracket, off to -infinity, off to infinity. Or you can do a filled in circle, like so. And up here we could have done an open circle, like so. That works too. Okay, so this is where we say more means or. Because we don't want to sit here and test out these points all the time. And so here's how we use that. Okay, so we have absolute value of 3. Our absolute value of x is greater than 3. Okay, so what this means, and this works, note that the absolute value is on the left-hand side, and this is greater than, which we're calling more than, because it rhymes with or, right? It helps us remember. And what this or business is as follows. What absolute value of x greater than 3 means is x is greater than 3, there I just drop the absolute value, or, okay, that's the or part, x is less than -3. So what did I do there? I changed the direction of the inequality. Okay, and I added on a negative. Add negative. Okay. So that is what you do, and then that will give you what you need to graph these things and do their interval notation. All right, so this gives 2 arms. These or questions will have 2 arms going off in different directions. Okay, so let's see here. Okay, 0, here's 3, here's -3, so this tells us x is greater than 3. All right, so there we go. And this tells us x is less than -3. And the or means both of these are included. It's different than an and where they have to overlap. An or means, okay, we'll include the stuff on the right and we'll include the stuff on the left, because it could fall in either or. Okay, so this says x is less than -3. There we go, all the stuff less than -3. Okay, it's like the opposite of a nest. There's this hole that you would fall right through. So the or case is the opposite of the less and nest case. They're always going to go off in these different directions to infinity and have this hole that you could fall right through. And then of course our interval notation immediately follows. A lot of times you go straight to interval notation. Oops, this is +3. There we go. Okay, and this works for anything. It doesn't have to be 3, right? This more means or business. Once you get it down for 3, you can see it for any c, right? If absolute value of x is greater than c, right, you just go to your number line, go up to c, go down to -c. It's the stuff right up to c and going off to infinity, and it's the stuff right up to -c and going down to -infinity. This is more means or. More means or. Either this left side or this right side. And the interval notation will always be -infinity up to -c, hop over, start again at +c, off to infinity. Okay, so less means nest and more means or is an easy way to remember how to do these problems. I recommend definitely taking a look at a bunch of examples, because it takes a while for this kind of thing to set in.